Welcome back, boys and girls. We're going to try lesson 11.2, which is entitled Degrees. And our essential question is, how are degrees related to fractional parts of a circle? Well, let's go take a look. All right, boys and girls, so what we want to think about is angles are measured in units of measurement called degrees. And when we think of a circle, I want you to think of a circle being able to be divided into 360 equal parts. Those 360 equal parts in one full turn around the edge of the circle equals 360 degrees. So you can have an angle that turns through 1/360th of a circle. That measurement of a circle equals 1 degree. Notice that the degree mark looks like an open circle up to the right of your number. It's really important that you put the degree sign in the exact place. Excuse me. If you have a turn through a circle that is 90 over 360 equals, well, let me think about that. That would be 90 degrees. And I think if I look at 90 over 360, how much of a turn would that be? Oh my gosh, you're absolutely right. That would be a 1/4 turn of my circle, around my circle. An angle that would run 180 degrees, or 180 out of 360 degrees, would be considered a 180 degree angle. 180 over 360, you're right, that would be 1/2 turn around my circle. I'm seeing how these fractional parts and these measurements are beginning to make sense. Let's continue. The example that we're going to work with today, boys and girls, has to do with the penny farthing bicycle. It was built around 1600, and it's right down here in the corner, so you can take a look. Boy, I bet that must have taken a little bit of balance. So what we're going to do in order to ride it, what we're going to do is we're going to talk about the wheel that you see here, the front wheel that you see here on this bicycle. So we're going to start here. It says, the angle between two spokes on the bicycle wheel turns through 10 360ths of a circle. What is the measure of the angle between the spokes? Well, let's see. We're going to use fractional parts to find the angle measure. So if we go down here and answer the questions, each 1/360th turn measures how many degrees? 1/360th turn measures, you're right, 1 degree. So 10 360th turns would measure how many degrees? You're right, 10 degrees. I want you to go back up here to this little box up here, this purple, and I want you to go ahead and answer the question. The question says, what part of an angle do the spokes represent? Do the spokes represent? You're right. The spokes represent the rays of the angle. The spokes that form the angle. Now let's go back to our question. So we decided that based on the center and the rays, each 1/360th turn measures 1 degree. 10 1/360th turns represents 10 degrees. So the measure of the angle between the spokes, between this point and this point is 10 degrees. You're right. How many degrees is the measure of the angle that turns through one whole circle? Let's take it again. How many degrees is the measure that turns through one whole circle? Well, if 1 degree is 1/360th, and a full turn is 360 over 360ths, then I guess if we're turning all the way around, the degrees would be 360 degrees in one full turn. You guys are really good at this. Let's keep going. Let's go for example 2. This time we're going to find the measure of the right angle. We've got our circle, we have our center point, we are creating, oh look, we've got a right angle symbol in there. So we're going to think, through what fraction of a circle does a right angle turn? All right, here's step 1. I'm going to write 1/4 as an equivalent fraction with 360 degrees in the denominator, because I know that's 1/4 of a turn. So 1/4 equals what over 360? So I'm going to think, 4 times 9 is 4 times 9 is 36. So 4 times what is going to be 360? You're right. 4 times 90. Oh, that's horrible. Let's try that again. 4 times 90. So 1/4 would be 90 degrees, 90 over 360. Now I'm going to write, step 2 tells me to write 90 over 360 in degrees. So an angle that turns through 1/360th of a circle measures what in degrees? You're right, 1 degree. An angle that turns through 90 360ths of a circle measures, you're right, 90 degrees. So a right angle must measure how many degrees? Now you're catching on, you're right, 90 degrees. Now remember, there's a little point here that says remember to write an equivalent fraction, multiply the numerator and the denominator by the same factor. We know that. Let's keep going. I want you to find the measure of a straight angle. Through what fraction of a circle does a straight angle turn? You're absolutely right. A straight angle will run through 1/2 of the circle. So let's write 1/2 as an equivalent fraction with 360 degrees in the denominator. So I write 1/2 equals how many degrees over 360? So the first thing I'm going to think of is, and this is what I'm thinking, I think that 2 times 18 equals 36. So if 2 times 18 equals 36, 2 times what number will equal 360? You're absolutely right. You've got your multiples of 10 down. So I would say 180. So 2 times 180 equals 360. So a straight angle must measure 180 degrees. Now, how can you describe the measure of an acute angle in degrees? Then I'm going to ask you to say, how can you describe the measure of an obtuse angle in degrees? Let's think about that. You're right. An acute angle has a measure that is less than a right angle, so it's got to be less than 90 degrees. An acute angle which we know is 90 degrees, Okay, super. How can you describe the measure of an obtuse angle in degrees? Well, we can think about that. An obtuse angle has a measure greater than 90 degrees, but less than what? You're right, it has to be less than 180 degrees or your straight angle. All right, good job. Now, I'm going to give you some practice problems to work on. All right, boys and girls, so here are the practice problems that I'd like you to work on tonight. This is a two-step process. Number 1 shows you a clock face, and number 2 shows you a clock face. And what I'd like you to do is tell me at first. So your first response will be, tell what fraction of the clock face is shown. Then you're going to explain how to find how many degrees each clock face or each minute hand has turned on each clock face. So remember, for number 1 and for number 2, you have 2 parts to your answer. All right. See you tomorrow.